Welcome to the AI for Career Success podcast by Curt Robbins. We're experts at AI coaching and helping professionals like you and your employees upskill in AI. I'm your host, Fred Jones, and with me today is my co-host, Daphne Blake. Welcome to episode 208.
Hi, everyone. It's really great to be here for this one.
Yeah, we've got a fascinating discussion today. So, Daphne, if you look at the financial news lately, it kind of feels less like we're operating in a traditional economy and more like, I don't know, a corporate landscape driven entirely by vibes.
Oh, completely. It's all vibes right now.
Right, like you read these headlines every single week where a CEO announces they're laying off like 10 or 20% of their workforce.
Yeah.
And the justification is always, oh, we are pivoting to AI.
Yeah, they point to these supposed exponential leaps in the tech, claiming that artificial intelligence is just making all these human roles obsolete.
Exactly. But then you look at their actual balance sheets and their hiring history, and you see that company profits are at all-time highs. And over the last 3 years, they literally doubled their headcount.
Right, which is a huge red flag.
It is. So I have to wonder if executives simply overhired during a boom and, AI is just the most convenient, futuristic-sounding scapegoat they have to appease Wall Street.
I mean, it functions as the perfect corporate cover story. An executive board gets to mask a strategic overhiring mistake while simultaneously signaling to investors that they're on the absolute bleeding edge of technology.
Yeah, it's a win-win for them.
It really is. But that corporate maneuvering relies entirely on a very specific narrative, right? The idea that AI is improving at this relentless, mathematically unstoppable pace.
Which brings us to the core mission for today. For you listening to this show, whether you're managing a team or writing code or just trying to future-proof your own career, you have to know if these trillion-dollar bets are based on reality.
Exactly, Fred. Are these massive industry shifts grounded in truth, or are we all just making decisions based on artificially inflated test scores?
And that is exactly what Paco Valdez explores in his article titled, CEOs Blame AI for Layoffs, but the benchmarks might be lying too. It was published in Paco's AI Lab on March 23, 2026.
It's such a critical piece because Valdez really challenges the core evidence that the industry uses to prove AI is getting smarter.
Yeah, because the entire narrative rests on benchmarks.
Right.
But to trust the narrative, we have to trust the scoreboard. And looking at his research, the scoreboard seems fundamentally broken.
It is completely broken. I mean, for a long time, the industry measured progress by treating large language models like students taking a standardized test.
Right, like the MMLU.
Yes, the MMLU, or Massive Multitask Language Understanding. It's basically a 57-subject multiple-choice exam. It covers everything from abstract algebra to virology.
Wow.
And when a new model drops, the parent company issues this massive press release celebrating that they hit like an 85 or 90% on the MMLU.
But testing a statistical prediction engine with multiple-choice trivia doesn't actually measure intelligence, right? It just measures retrieval. Like, if I memorize an encyclopedia, I can ace a trivia night. But that doesn't mean I can synthesize that information to solve a brand new problem at work.
And Valdez points out that when researchers actually force the models to reason, the whole illusion of superintelligence just shattered.
Yeah, they released a harder version of this test called MMLU Pro. They increased the answer choices from 4 to 10 just to eliminate lucky guesses, and they rewrote the questions to require multi-step logic.
And the results were highly revealing. When models transitioned from the original test to the Pro version, their scores plummeted by 16 to 33 percentage points across the board.
A 33-point drop is huge.
It's massive, and the mechanism here is critical to understand. When a model takes the original MMLU, it relies heavily on statistical proximity. So if the words mitochondria and powerhouse appear together millions of times in its training data, it easily predicts the right letter.
Right, it's just pattern matching.
Exactly, but MMLU Pro requires the model to hold a logical constraint in its memory across several steps. And because these models don't actually possess a persistent internal workspace for abstract thought,
They just predict the next token.
right, so the moment a question requires holding 3 competing variables in tension, the statistical chain breaks, and the model fails.
Which completely changes how you, as a professional, should view the tools you're paying for. If you're using AI to draft an email, predicting the next likely word is totally fine. But if you're using it to architect a complex business strategy, A 33-point drop in reasoning ability is catastrophic.
Oh, for sure. And we see this exact same failure point in coding, which is arguably the most hyped enterprise use case right now.
Yeah, let's talk about the coding tests.
So the standard coding test is called human eval, where the model just writes a short, isolated Python script. But Valdez compares that to a newer benchmark called SWE Bench.
And SWE Bench asks models to fix actual bugs in messy, real-world GitHub repositories.
Yeah, exactly. Human eval is like asking a student to write a clean algorithm on a whiteboard. It just tests syntax. But SWE Bench tests actual software engineering.
Because it drops the model into thousands of lines of legacy code.
Right, and it asks it to figure out why a specific button is crashing the database. On SWE Bench, the models struggle significantly more because navigating real-world context requires a fundamental understanding of system architecture.
Not just spitting out a memorized snippet of Python.
Exactly, Fred.
Okay, but let's talk about the hard sciences, because surely chemistry and physics provide an objective baseline. Valdez mentions the GPQA, which stands for Graduate Level Google Proof Q&A.
Oh, this one is wild.
Yeah, these are PhD-level questions, so incredibly difficult that human experts, given 30 minutes and full access to the internet, only score about 34%.
Yep.
Yet AI models routinely score highly on the GPQA, leading companies to claim their AI has achieved PhD-level intelligence.
But if models are failing at basic multi-step logic on the MMLU Pro and failing at real-world coding on SWE Bench, how are they magically achieving PhD-level breakthroughs in quantum physics?
Exactly. It doesn't add up.
And that contradiction leads directly to the core problem. The metrics are easily manipulated. But before we get to the technical manipulation, we have to look at the ultimate vibes scoreboard, which is the chatbot arena run by UC Berkeley.
Ah, yes. The beauty pageant.
Pretty much. It uses blind A/B testing. You type a prompt, 2 anonymous models generate an answer, and you vote on which one you prefer. The winner climbs the leaderboard using an ELO rating system, kind of like chess rankings.
But using a beauty pageant to measure capability is just a terrible idea. It's like trying to find the best structural engineer by having 2 people present to a crowd.
Right.
One engineer gives you a dense, mathematically sound blueprint. The other engineer builds a flashy cardboard model and speaks with overwhelming confidence.
And the crowd votes for the cardboard model.
Every time.
Yeah.
Because it's approachable. And suddenly that guy is put in charge of building a bridge. Valdez points out that what humans prefer and what is factually correct are often deeply misaligned.
They really are. Humans are heavily biased toward formatting, authoritative tone, and length. If Model A gives a concise, accurate answer, and Model B gives a hallucinated, incorrect answer, but uses bold text, bullet points, and an enthusiastic tone,
People vote for Model B.
a massive percentage of users will vote for Model B. They are voting for the aesthetic of intelligence, not the substance.
So if the chatbot arena is just measuring human bias, and the academic benchmarks are just measuring trivia retrieval, it paints a pretty bleak picture.
It does.
But it gets worse, because the trillion-dollar valuations tied to these tests create a massive incentive to actively game the system. I mean, if your stock price depends on beating the MMLU, you are going to make sure your model beats the MMLU.
Obviously. And Valdez highlights research from 2025 and 2026 showing exactly how companies hack the report card, starting with the data contamination.
Which is basically the equivalent of a student gaining access to the teacher's answer key the night before the final exam.
Exactly. Valdez cites a damning 2025 paper by Chen and colleagues. They investigated the training data of these models and found massive systemic leakage.
Like how much leakage?
Well, in one version of ChatGPT, approximately 40% of the exact coding problems from the human eval benchmark were explicitly included in the model's pre-training data.
Okay, but let me challenge that for a second, Daphne. Isn't that exactly how human beings learn?
How do you mean?
Like, if I want to learn to code, I go to a textbook, I read thousands of examples of good code, I memorize the patterns, and I apply them. Why is it considered cheating when AI does the exact same thing?
That's a great question, but there's a huge difference. A human abstracts the underlying concept from the example. If you learn the concept of a loop in Python, you can apply that concept to a completely novel problem you've never seen before.
All right, okay.
A large language model, however, is performing statistical pattern matching. If the test question is in the training data, the model isn't learning the concept of coding, it's simply predicting the text string of the answer it has already ingested.
Ah, I see.
And to prove this, Scale AI created a brand new math benchmark called GSM-1K. The underlying math concepts were functionally identical to the famous GSM-8K test, but they changed the wording and the numbers so the models had never encountered them before.
And the models failed because they didn't actually know how to do the math?
Precisely. Some model families saw their accuracy drop by up to 13%. Furthermore, the researchers established a direct statistical correlation.
Which was?
The models that were the absolute best at reciting the old public test questions verbatim were the exact same models that failed the hardest on the new private test questions. They were heavily over-optimized for memorization, not calculation.
Wow. And Valdez uses the strawberry problem from the Chen paper to perfectly illustrate this mechanism. If you ask a major language model how many R's are in the word strawberry, it immediately answers 3.
Right, it looks like it's intelligently analyzing the characters.
But it only knows the answer because the strawberry problem became a viral debate on social media, meaning the specific string of text containing the question and the answer was absorbed into the training data millions of times.
Yeah, and the tokenization process explains exactly why it fails when you alter the parameters. Large language models do not read letters the way humans do. They process text in chunks called tokens.
So the word strawberry might be broken into a token for strawed and a token for berry.
Exactly. The model has no internal mechanism to look inside the token berry and count the mathematical characters. So, as Valdez points out, if you give the model a completely novel word that hasn't been heavily debated on the internet and ask it to count the letters, it completely fails.
Unless you explicitly prompt it to write and execute a separate Python script to count them for it.
Exactly.
Okay, so if the model's intelligence is just an illusion of token probability, that brings us to the most bizarre finding in the article: prompt sensitivity.
Oh, this fundamentally redefines what we mean when we say a model is smart.
Yeah, Valdez cites a 2024 study by Sklar and colleagues regarding how fragile these systems truly are. What did they find?
Sklar's team discovered that you can take the exact same reasoning question, keep the core text identical, but simply alter the superficial formatting of the prompt, like changing a bullet point to a dash or adding a space, and the model's performance wildly fluctuates.
That's crazy.
On Meta's Llama 213B model, a simple formatting change caused a 76-point swing in accuracy.
Wait, really? A 76-point drop just from changing a bullet point to a dash?
Yep.
That means we aren't testing intelligence at all. We are testing prompt luck. Like, if a human takes the bar exam and the questions are printed in Times New Roman font, they pass. But if the exact same questions are printed in Arial font, they suddenly forget the law.
Right.
We would never call that human intelligent. Why does a visual formatting choice break the mathematical output of an AI?
It goes back to how the models calculate probability in a high-dimensional vector space. Every single token, including a dash or an asterisk, shifts the mathematical context of the prompt.
Okay.
So when you change a bullet point to a dash, you slightly alter the mathematical trajectory of the entire sentence. If the model's understanding of the concept is shallow, that tiny trajectory shift is enough to push the model's next token prediction into a completely different, incorrect probability distribution.
Which means a tech company testing their new billion-dollar model doesn't actually have to build a smarter model. They can literally just run the exact same reasoning test through hundreds of different prompt formats, find the one specific arbitrary combination of asterisks and line breaks that accidentally triggers the correct mathematical path, and then publish that highly inflated score.
Let's take a brief break for a special message from our producer, Curt Robbins.
Hi, this is Curt Robbins. First, thanks for listening. I truly appreciate your support. I want to let you know that I'm currently accepting new clients. My rates are affordable, and I have more than 25 years of experience working for enterprise companies like Microsoft, Northrop Grumman, Oracle, PNC Bank, FedEx, USAA, and Wells Fargo, among many others. If you want to improve your IT documentation and communications, hire me. I deliver fast, know how to use AI to improve efficiency and accuracy, and love going the extra mile to satisfy my clients. Thank you for subscribing and listening. Back to you, Daphne and Fred.
Welcome back to the AI for Career Success podcast, where we help you get smarter than your competition by coaching you in AI.
So before the break, we were just discussing how companies can manipulate prompt formatting to inflate their scores. And that perfectly introduces the concept of cherry picking, which Valdez covers extensively by citing a 2025 study called the leaderboard illusion.
Yeah, if you were listening to this and wondering why every single week a new AI model claims to be the new state of the art, this study explains the parlor trick.
It really does.
The researchers analyzed the chatbot arena. They found that before Meta officially released Llama 4, they internally tested 27 different versions of the model on the arena. And Google did the exact same thing with Gemini, testing 10 different versions prior to release.
Which, sounds like standard product optimization until you understand the statistical variance of the arena.
Because it relies on subjective human preference, so the results are incredibly noisy.
Exactly. By submitting 10 or 20 slight variations of a model, a company isn't rigorously finding the smartest version, they are simply pulling the lever on a slot machine. The mathematical variance alone dictates that if you test enough times, one version will randomly secure a massively inflated ELO score. The company then publishes that specific jackpot score and hides the rest.
And Valdez highlights the ultimate proof of this statistical noise. The researchers submitted the exact same, identical model to the arena twice, just operating under two different anonymous names.
And what happened?
The exact same code generated a 17-point difference in their final leaderboard scores.
Wow.
It is purely random variance. Yet, executives are sitting in boardrooms looking at a 17-point jump on a chart and using it to justify laying off thousands of employees because the AI is supposedly exponentially improving.
This creates a highly dangerous environment for professionals trying to implement these tools. Let's look at the 2026 paper by Yang and Wang, which Valdez calls the benchmark illusion.
Yeah, this is where it hits the real world.
Exactly. What happens when a model legitimately achieves an A+ on these tests, but you ask it to actually execute work in your business? Yang and Wang analyzed models that achieved nearly identical top-tier scores on both the MMLU Pro and the GPQA.
So on paper, these models are completely interchangeable.
Right. If you're a director of operations and two different software vendors offer me AI models that both score an 85% on the benchmark, I assume I can buy either one and get the exact same quality of work.
That you won't?
No, you won't. When the researchers broke down the data, they found that these identically scored models actually disagreed with each other on up to 66% of the individual questions.
That is why
They're getting completely different things right and wrong, meaning their internal logic and blind spots are entirely distinct.
that is a staggering operational risk. I mean, if you are a listener who manages a data analytics team and you switch your underlying AI provider just because a new model topped the leaderboard, your entire workflow might silently break. Valdez points out that when researchers use these identically scored models to annotate complex scientific data, simply switching from Model A to Model B changed the final estimated results by more than 80%.
And in some instances, swapping the equally scored model entirely reversed the conclusion of the scientific study.
It's terrifying. The aggregate score completely hides massive, unpredictable variations in how the models behave in a production environment.
You really cannot blindly trust a generalized number to dictate a specialized workflow.
And Valdez brings this reality home with the launch of DeepSeek v3.2 in late 2025. On paper, it was a world beater. The benchmark charts looked incredible.
Right, everyone was talking about it.
But when actual software engineers integrated it into their daily workflows for real coding tasks, the overwhelming consensus was that it was just, well, mid.
Yeah, just average.
It performed adequately, but it completely failed to live up to the revolutionary hype suggested by its test scores. Valdez quotes Martin Sapp from Carnegie Mellon, who summarizes the entire situation. Benchmarks today don't reflect how people actually use AI. They're misaligned, often based on factoid-style tasks that resemble trivia, not real-life queries.
So how should a professional synthesize this information? Because Valdez is highly careful to ensure the takeaway isn't just pure cynicism.
Right.
AI is not a scam. The tools available today are incredibly powerful. Language models, when applied correctly, drive massive efficiency.
Oh, absolutely.
The models are legitimately improving over time. The technology itself is not the danger here.
The danger is the exponential narrative. It is the false promise that capability is doubling every 6 months, which causes companies to radically destabilize their workforce in anticipation of a superintelligence that isn't actually arriving on schedule.
Exactly, Fred. For you, the listener, navigating your career right now, understanding the benchmark illusion is incredibly empowering. You do not need to operate in a state of panic, assuming an artificially inflated leaderboard champion is going to automate your specific, nuanced role by next Tuesday.
But conversely, you cannot afford to pause your own learning.
No, definitely not.
Because the durable, long-term career strategy isn't waiting for the perfect, flawless God model to be released. Organizations haven't even begun to figure out how to properly integrate the noisy, prompt-sensitive, hallucination-prone models we have right now.
Exactly.
The true career opportunity lies in becoming the professional who knows how to pilot these imperfect tools.
Right. If you know how to build a robust system around an AI's limitations, if you understand how tokenization impacts prompt engineering, and if you know how to verify outputs rather than blindly trusting a vendor's claims, you become indispensable.
Critical evaluation and strategic implementation are capabilities that no language model can automate. Being the human in the loop who understands the underlying mechanisms of the technology will always be more valuable than the technology itself.
That is perfectly said.
Which leaves us with a final vital question to evaluate within your own career and company. We began by looking at CEOs who lay off staff, blame AI, and point to soaring benchmark scores as their justification.
Right.
But if those executives are relying on a statistical mirage, a gamified, data-contaminated, cherry-picked leaderboard score to justify masking their own strategic failures, you have to critically evaluate your own organization. How much of the broader corporate AI strategy being implemented in your industry right now is based on tested, ground truth capability? And how much of it is just panicked leadership blindly chasing a trend because they saw a shiny, formatted number on a broken scoreboard? Protect your career by testing the tools yourself, mastering their actual constraints, and never letting corporate vibes dictate your reality.
Couldn't agree more.
Thank you for listening to the AI for Career Success podcast from Curt Robbins, where we help you get smarter than your competition. Please buy us a coffee, and remember that we're experts at coaching you and your employees about AI. We'll see you next time.